These are the chapter 9.2 notes, sum and difference identities, and this is page 1. So real quick, you've noticed hopefully this box up here is the same one you see if you open the homework set, top left corner, right corner, and it just kind of gives a list of everything that we need to be going through in this section. It's also a double check to make sure you've got the right homework if you're comparing with what's on the notes. Okay, so we have the unit circle for reference up here in the top right. And so example 1, we want to use what we know about exact values, if we have them, to determine the following, and then we'll verify with the calculator. So first off, A, is it true that the sine of 2 pi over 3 equals the sine of pi minus the sine of 3? That would make this really easy for us. So let's take a look and see what happens. The sine of 2 pi over 3, if we are taking a look at our unit circle here, here's our 2 pi over 3. The sine is the y coordinate, so the sine of 2 pi over 3 is the square root of 3 over 2. We want to see if this is equal to the other side. And so we've got the sine of pi. Here's our pi. Again, the sine is the y coordinate. And so we get 0. And we are looking at the sine of pi over 3. Pi over 3 is right here in the first quadrant. Sine is square root of 3 over 2. And so on the left-hand side, we have positive square root of 3 over 2. On the right-hand side, we've got 0 minus the square root of 3 over 2, so negative square root of 3 over 2. So no, these are not equal. A little bit of a bummer. Let's try cosine. Is it true that the cosine of 75 degrees equals the cosine of 45 degrees plus the cosine of 30? Well, I can find exact values for cosine of 45 and cosine of 30, but not for the cosine of 75. So I'm just going to go ahead and use a calculator for all of this. If I plug in the cosine of 75, I get 0.2588. If I plug in the cosine of 45 degrees plus the cosine of 30 degrees, remember that my calculator needs to be set to degrees in terms of the mode. You will get something different if it's still set to radians. Cosine of 45 degrees plus the cosine of 30 degrees, I get 1.5731. Those are not equal. So no, it's not true that the cosine of 75 degrees equals cosine of 45 plus cosine of 30. So we can't just break that argument apart into two separate pieces. So we have to take a look at ways to be able to use these. Now for A, we know the values for 2 pi over 3 and the sine at pi and the sine at pi over 3. But for B, if we need to find something like the cosine of 75, we're at a little bit of a loss, okay, because that's not one of the values on our unit circle. So we are going to take a look here at special formulas I've grouped together in terms of cosine and then sine and tangent, because the formulas for the cosine look similar, and you just have to pay a little bit of attention to see where those differences are. So we have got the cosine sum first. Cosine alpha plus beta, that equals cosine alpha cosine beta minus sine alpha sine beta. So we've grouped cosines of both angles together, sines of both angles together, and this sign in the middle is the opposite of what's in the argument. So alpha plus beta in the argument means I'm subtracting the parts in terms of the formula. Take a look at the difference formula. When we have cosine alpha minus beta, again, the same first term, cosine alpha cosine beta, the same second term, sine alpha sine beta. This time, though, we are adding those together. Okay, so the signs change. Sometimes you will see it this way. This symbol here you've seen before, we call it plus minus. This one looks a little different. We're going to read that minus plus. The way to read this formula is if I'm using the top operation over here, so cosine alpha plus beta, I'm using the top operation on the right-hand side, cosine alpha, cosine beta minus sine alpha, sine beta. So it's just a way to kind of compact it into one formula and not have to write two of them out each time, okay? So exercise 2, we want the exact value of cosine pi over 3 minus pi over 4. And so this is a difference formula for cosine. And so just to remind myself, I'm going to go ahead and write this out. So as I go to plug things in, I don't have to think too hard and I don't make a mistake. You'll find as we go through these, a lot of repetition, a lot of stuff looks the same. So you want to be very careful and make sure you are not mixing things up. So my alpha is pi over 3. My beta is pi over 4. Alpha is still pi over 3. And beta is still pi over 4. Okay. Notice the minus is taken care of in terms of the formula. It's not attached to the pi over 4. So the cosine of pi over 3 is 1/2. Cosine at pi over 4 is square root of 2 over 2, plus the sine at pi over 3 is square root of 3 over 2. That was awesome. Pi over 4 plus sine. Okay, where are we? Sine of pi over 3, square root of 3 over 2. Sine of pi over 4, square root of 2 over 2. We're going to multiply these terms together. I've got 1 times square root of 2 is square root of 2 over my denominator looks like 2 times 2, which is 4. Plus square root of 3 times square root of 2, we can multiply under that radical. We get square root of 6 over that denominator, 2 times 2, which is 4. We have a common denominator, so we can combine these. Keep in mind this asked for an exact value, which means we're not plugging anything into the calculator. We don't want decimal approximations. We are going to leave this answer in terms of the radicals involved.